Hi, this is Professor Monty again, and we're going to look at finding concavity and inflection points. Well, concavity comes from the second derivative. So let's go ahead and take the first derivative. We get 3x squared minus 6x minus 24 onto the second derivative, 6x minus 6. And so to find concavity and inflection points, we take the second derivative, we set it equal to 0. So we set that equal to 0, we solve it, add 6 to both sides. Divide by 6, we get x equals 1. Well, 1 is kind of a critical value for concavity. The only place I can change concavity is when the second derivative equals 0. Let's see if it actually does change concavity there. So I'm going to do a little chart of signs. I'm going to put this critical value 1 up there, and that's going to break my number line into negative infinity to 1, and then 1 to infinity. And I'm going to test a number in each of those intervals. So I'll test, say, 0 over here and 2 over here. And what I'm going to do is I'm going to plug them into the second derivative. So in f double prime, I plug 0 in. 6 times 0 is 0, minus 6 is negative 6. I'm just looking for the sign. I get the second derivative negative there. Well, that means the function is concave down. So I know my function is concave down in this interval. Similarly, I plug in 2 to the second derivative, and I get 6 times 2 minus 6, which is 12 minus 6 is positive 6. Again, I just care about the sign. If the second derivative is positive, it means it's concave up there. And so now I can actually answer my question. So I know it's concave up from 1 to infinity. I know it's concave down from negative infinity to 1. And the definition of an inflection point is when it changes concavity. Well, I saw it change concavity at 1. So the inflection point is at 1, comma, well, to find the y value, I have to plug that 1 into the original function. So I get my y value is f of 1. So I just plug 1 up here for all the x's. I get negative 21. That's my y value. And so quick as that, I found my areas of concave up, my areas of concave down, and I found my only inflection point here was at 1 comma negative 21. So anyway, that's the idea. Concavity and inflection points, second derivative. Take the second derivative, set it equal to 0, solve, and then check the sides. All right, if you have a between, if you have more than one critical value, you have to check in between. But that's the idea. We're looking at the second derivative for concavity and inflection points. All right, if you haven't done so, please subscribe to my channel. That helps me make these videos. But other than that, if you have any comments or other ideas, videos you want me to make, just put those in the comments and I'll hopefully get some more videos made. All right, best of luck to you. Remember, you can do this. All right, bye.